Bismillahirrahmanirrahim. Hoping you all will be doing fine. Let's start with the problem that we even discussed in the lecture just before the mid-exam, and we partly discussed it. So let's complete this problem. But anyhow, I will start it from the beginning once again, and we will discuss the whole problem, trying to finish it today. This is basically the network for a 3-bus system, where the first bus is the slack bus, the second bus is the load bus, having only active power consumption, and the reactive power is 0. And the third bus is the voltage control bus, where the voltage magnitude is fixed, it's 1 per unit, and the active power that is injected into the bus is 0.5 per unit. All these buses are connected by transmission lines with only susceptances, meaning to say that the conductance is 0. So this is a lossless transmission line. All these are lossless transmission lines with susceptances given. B12 is equal to minus J4, B13 is minus J4, and B23 is equal to minus J2. So we are supposed to solve this problem, and the different tasks that we are supposed to perform are: number first is to formulate the bus admittance matrix. The second part is regarding the calculation of the voltage at bus 2 and the angle at bus 3 as the voltage magnitude is given. And the third part is related to the active power flow on all these branches and the injected power at the slack bus. So these are the 3 parts which we are supposed to perform. Now, starting with the first part, where we are supposed to find the bus admittance matrix. So A part is related to the formulation of the bus admittance matrix, and that would be equal to, as you know from the general formulation, that this will be a 3 cross 3 matrix with the first entry equal to the sum of all the admittances connected to bus number 1, which is equal to this one plus this one. So that become minus J8. The second entry, which is Y12, that will be equal to the negative sum of the admittances connected between bus number 1 and bus number 2. So the negative sum with already a negative value there, that become J4. Similarly, the third entry, which is Y13, that will be equal to the negative sum of the admittances connected between bus 1 and 3, that become J4 again. And we know that this is a symmetrical matrix, meaning to say that Y12 will be equal to Y21, so that is again J4. You all know that. We have discussed it before quite in detail, and we even discussed the general form of the bus admittance matrix, but just to refresh your memory. The second entry, which is Y22, will be equal to the sum of the admittances connected to bus number 2. So one is this admittance, one is this one, so the sum of these two become minus J6. And the third entry, which is Y23, will be equal to the negative sum of the admittances connected to bus number 2. So that it become this one, which is Y23, the negative sum of the admittances connected between bus 2 and 3. So the negative sum, so already a negative value, make it J2. The third row with the first entry Y31, as it is symmetrical matrix, so that become the same as this one, J4. The second one with the same as a symmetrical matrix, so this will be J2, as Y23 will be equal to Y32, and the third entry, which is Y33, becomes the negative sum of all the sum of the all the admittances connected to bus 3, so that become this one plus this one, which become minus J6. So this is now the bus admittance matrix for this given network, with all the entries are mentioned in the matrix. That is the first task that we have performed. The second task is, although we will use this admittance matrix in the preceding tasks, so let me keep it here, and we start with the second task. The second task is related to the calculation of the voltage at bus 2 and angle at bus 3. But as you know that this is basically a voltage control bus, so still to calculate the angle at this bus, we need to find the expression for the voltage, and that will basically give you the angle. So we will find the whole expression where we will get the magnitude of the voltage, although it is fixed, but that will help us in calculating the angle as well. So we are supposed to find the voltage, the angle and the voltage magnitude at bus number 2, which is the load bus, and the angle at bus number 3. So let's proceed with the task number 2. That is task B. And we are supposed, I forgot to say in the beginning that we are supposed to solve this task using Gauss-Seidel algorithm. We have discussed, even we derived the general form of this algorithm before the mid semester. So let me write the general form of the Gauss-Seidel algorithm, where we know that the voltage at any bus K, rho plus 1, where rho is basically the iterations, equal to 1 over YKK PK minus JQK over UK rho conjugate minus sum of all the terms. It's in this form, basically J equal to 1 to N, where N is the number of the buses in a given network, Y, K, J and U, J, O, and J should not be equal to K. So this is the general form of the Gauss-Seidel algorithm. So now using this algorithm, we are supposed to find the voltage at bus 2 and the angle at bus 3. So let's start with the load bus, for which K is basically 2. So we start with the load bus and K equal to 2. So now for K equal to 2, which is the load bus, this expression become U2 rho plus 1, where I mentioned before rho is the iteration, become equal to 1 over Y22 P2 minus JQ2 over U2 rho conjugate minus J equal to 1. We start with that, j equal to 1, but j should not be equal to 2k, which means j should not be equal to 2. And we have a 3 bus system, so we start with 1 and then j further equal to 3, as j should not be equal to 2 because k is 2. So as k is 2, so it become minus y21 u1 rho minus, as minus sign is here, minus y23 u3 rho. So now according to the sign convention, if you remember before, because this is the load bus, bus number 2 is the load bus, so for the load bus both these will be negative. So as P2 is given, which is 1 per unit, and Q2 is 0, so we put these values and we basically start what we call a flat start. So for the flat start, as you remember, for in the flat start we assume the magnitude of the voltage equal to 1 and the angle at that particular bus equal to 0. So what we do now, because in this expression we need the angle at bus number 3, because the magnitude is given, so we need to assume the angle for this voltage, and also we need to assume the first value for the voltage at bus 2, as it is a iterative method. So what we do now, flat start, and for the first iteration rho is 0. So assuming these conditions, we put u2 0 equal to 1 and psi 2 0 equal to 0 degree. Further we assume now the angle at bus number 3, because the voltage magnitude is given, which is 1 per unit, so the angle for the 0th iteration is assumed as 0. So now putting these values in this expression, the admittances as well from the bus admittance matrix and the P2 and Q2 value, but knowing that it's a load bus, so the values for both P and Q will be placed as negative. So putting these values now, y22, which is this one, so that is minus j6, so 1 over minus j6, 1 over minus j6, and now P2, because at the load bus it is 1 per unit, so we put a negative sign because a load bus, minus j as Q is 0, so we put it a 0 value, over this one, the 0th iteration, the angle is 0, so this become 1 minus y21. So if looking here, y21, which is this one, so which is j4, so minus j4 into the voltage magnitude, into the voltage, which is again at the slag bus, the voltage magnitude is 1, the angle is, as you know, the angle at the slag bus is 0, so that become 1, and minus y23, which is this one, which is j2, so that become minus j2 into u3 for the 0th iteration, so u3 with the magnitude given as 1 per unit and the angle we assume 0, so that become 1. So now calculating this expression, we get for u2 1 as rho is 0, so this putting rho equal to 0, it become u2 1, and that becomes at the end, that become 1 minus J 0.166. In the polar form, it can be written as 1.0138 angle minus 9.46 degrees. So we have now calculated the value for the first iteration for the voltage at bus number 2. Now we proceed to the bus number 3. So bus number 3 is the voltage control bus, where the voltage magnitude is given, but we are supposed to find the angle. So now again, as I mentioned before, we are supposed to find the whole expression, and from that we will determine the angle. So now again, starting with the general form of the Gauss-Seidel algorithm, which is given here, we start with that expression. So for the k equal to 3, which is the voltage control bus, the expression for the voltage become U3 rho plus 1 become equal to 1 over Y33 P3 minus JQ3 divided by U3 rho conjugate minus Y31 as per this algorithm, k equal to 3, so K31 U1 minus K32 U2, and J should not be equal to K, which means J should not be equal to 3. So Y31 U1 rho minus Y32 U2 rho. So as this is the voltage controlled bus, basically, which is this one, is a voltage controlled bus. So we now P3, and we don't know the value of the Q which is required in calculating the voltage at this bus, as it is a voltage control bus and the P is injected. So according to the sign convention, this will be taken as positive. So but before we calculate the voltage, we need to find Q3 because it is not now. So now Q3 has to be calculated, which from the formula, we already discussed this before, the general expression for the Q K at any bus equal to summation of all the terms J start from 1 to N Uj Uk and then G K J sine of psi K J minus B K J cos of psi K J. So this is the general expression for calculating the value of the reactive power at a bus. So now for bus number 3, we are supposed to find this value, so we use this expression. And as you know that in the given network, the conductances are 0, only susceptances are given, so this term becomes 0, and we will only consider this term where the B susceptances are given. So using the admittance matrix, this expression, we will calculate the Q power. So now, taking k equal to 3, as it is bus number 3, this become the expression become Q3 become U1 magnitude, U3 magnitude, and knowing this term is 0, it become minus B31 cos of psi k minus psi 1 j start from 1 to 3, and we know that subscript kj means this angle is the difference of the angle between bus k and bus j. So this become the first term. The second term become U2 U3 minus B32 cos of psi 3 minus psi 2 plus another term where j equal to 3, so that become U3 magnitude, again U3 magnitude, and minus B33 cos of psi 3 minus psi 3. So now we have to put the values of the susceptances from the bus admittance matrix, and also we have to put the voltage magnitudes. So this is the slack bus voltage, which is 1. U3 is also the voltage at the voltage control bus, so that is also 1, and we also need U2 here. So we have determined before the voltage for the load bus, which is 1.0138 minus 9.46 is the angle, and this is in the rectangular form. So now putting these values, the value for the voltage of bus number 2, and we know the magnitude at the other two buses, which is 1 per unit. So now putting these values, this one and the other two, which is equal to 1 per unit, and also the susceptances from the bus admittance matrix, which is this one, we putting values, it become 1 and 1, so that is this is become, and B31 which is J4. So now B3 is basically 4, and we have a negative sign here, so that become minus 4 cos of but even before that, one thing that I should mention, we have assumed the flat start. So for the flat start, the psi 3 was assumed as 0, and yeah, psi 3 was assumed as 0, and as I mentioned, we have determined the value for the voltage at bus 2. So now using the angle, which is minus 9.46, and the magnitude, this one for the U2, we will calculate this one. So it become minus 4 cos of psi 3 minus psi 1. We in the flat start we have assumed this is 0, and this is the angle at the slack bus, so this is also 0, so it becomes 0 degree plus the second term. This is basically, as I mentioned before, this is 1.0138, this is the magnitude of it, so 1.0138 The other one is basically the voltage at the voltage control bus, which is 1, so that is 1, and it become multiply by minus B32, which is B32, which is J2, so B32 is 2, so that become minus 2 cos of the angle between bus number 3 and bus number 2, as this is assumed 0, and this angle is minus 9.46, and already we have a negative sign here, so this become positive, that become 9.46. The third term, which become this is 1, as it is at the voltage control bus, this is 1, and this angle becomes 0, and the B33, if one look here, that is minus 6, and we have already a negative sign here, so that become 1 1 minus 6, and already in the bus admittance matrix we have minus 6 value there, so that become positive 6 into cos of 0, cos of the 0 angle. So now putting the value, we determine the Q31, by the way we put here 1, that is for the first iteration, the value of the Q3 for the first iteration. So now we put here all the values, we get it approximately equal to 0. This is this become minus 4, that become 6, and this is almost, if we determine the value of the cos of 9.46, so that is multiplied by 2, yeah. One thing which I forgot to write here, yeah, if we multiply basically this one, the whole term, this one 1.038, so that is cos of 1.0138 into minus 2, cos of 9.46. So that one can, if you, I don't think so it will be more visible, but that is the value. So this one, this whole term, this one, it is approximately equal to 2.0000, so 4 times 0, so that's why it is the value for the Q31 is 0. This is just as I put dot here, so I need to, so the value for the Q31 is 0. Now we will put this value of Q31 here, and the other values we will determine the value for the voltage at bus number 3 for the first iteration. So now putting the values of Q3, which is 0 here, and other values, we will now proceed to that step. So now again using the expression that we wrote before, which is this one, so now it become the U3 rho plus 1, it become as per this expression Y33, so we put it from the bus admittance matrix. If one look here, that is minus J6, and the other values we have determined. So putting these values, U31 rho plus 1 become 1 over minus J6, and P2 which is positive as it is the injected power, so that become 0.5 minus j as we have determined the value for the q just before that arrived to be 0. So now u3 row, which we assume in the flat start is 1 with an angle 0, so that become 1 minus this term minus this term which is y31 u1 and then y32 u2, but this value should be put the one we have calculated here, that is 1.0138 minus 9.46. so putting the value of u2 in from the first iteration and the other values, this become minus j4 u1 as it is 1 angle 0 minus j2 and u2 in the first iteration, which is 1 minus j 0.1 minus j, which is this one, 1 minus j 0.166. So 1 minus j 0.166, that become like this. So now calculating it the value become 1 plus j 0.028. In the polar form it become 1, almost 1, approximately 1 with an angle of 1.6 degree. So if we even convert that into the polar form, 1 plus 0.028, and if we convert it into the polar form, it is approximately 1.00039 with an angle that is 1.6. so this is basically, and for it's important to mention here, this is the first iteration, so the rho would be equal to 0. So for rho equal to 0, this become u1, so u31, so that become a magnitude of 1.6. and as you can see that even in the first iteration, the magnitude for the voltage at bus number 3, which is mentioned here, is 1. so this even after the first iteration we get almost the same value as it is given in the task, but this expression helps in calculating the angle. So without basically this expression we can't determine the angle. So after the first iteration, the voltage magnitude is approximately 1 and the angle is 1.6 degree. Now we go for the second iteration. We put the slides in So now we go for the second iteration and we exactly repeat the same things. We will calculate once again the voltage at bus number 2 using the same expression that we have mentioned here. So we will now go for rho equal to 1, because we in the first iteration we put rho equal to 0, and now we will put rho equal to 1, and now we will use the value of the first iteration here as well as here. So and this is a slack bus, so that will remain 1. So now using the same expression, this one, putting the values of the first iteration which we have determined, we will now calculate the value of the voltage at bus number 2 for the second iteration. So let's proceed to that. Now so now the u2 for rho equal to 1, let me write it again, for rho equal to 1, so that let's start it again. So that become u rho equal to 1, and it is in the expression it is rho plus 1, so that become 2 equals 1 over minus J6, 1 over minus J6 with an angle that with the other values that we are supposed to put. So the active power at the active power consumption at the load bus is -1, and the other would be the Q power is 0, so divided by now we have to put here, this is important to mention here, we have to put now the value of the voltage for the first iteration. We have determined it, and that arrived to be this one. So now we will put this value with a conjugate of it, so this become positive. So now putting this value, for the first iteration with taking the conjugate as well, so that become 1 plus J 0.166 minus J4 with the voltage of the slag bus, which is 1, minus J2, that is Y23, which is this one, and U3 row. So we have just determined the value for the U3, which is found to be this one approximately. So now we put this value here, and we have to we put this value, so it become now minus J2, 1 plus J 0.028, and that become now, after all the calculations, it becomes 0.973 minus J 0.1715, that is U2, and in the polar form it become 0.988 with an angle of minus 9.99 degree, approximately 10. If we compare it with the angle in the first iteration, so that was 9.46, this become minus 9.99, and the voltage magnitude dropped from 1.0138 to 0.988. We will discuss that after some more calculation. So now this is the voltage of at the bus number 2 for the second iteration, and now we calculate in the similar way. We calculate now the voltage at bus number 3 for the second iteration, where this value will be used. So again, following the same steps we did before, that is, we now calculate the voltage at bus number 3 for the rho equal to 1, because we have already determined for the first iteration. So now we will go for the second iteration, where rho will be equal to 1. So now we again follow the same steps. We put this expression, and we have to now calculate the value of the Q32, accounting for the updated values of the voltage at bus number 2 and also the angles. So now again, following the same pattern, the same procedure, first we have to calculate Q3, and then we put this value, the value we will determine, we will put it in the expression, and also the other values, and the value of the U3 for the first iteration, taking the conjugate of that, we will calculate the value of the voltage at bus 3 for the second iteration. So exactly following the same procedure, I will just put the values because the procedure we discussed before. So now we will now go for the voltage at bus number 3, so that U3 2 as rho equal to 1, so that become as here rho, when we put rho equal to 1, yeah, so that become 2. So here the same, we put rho equal to 1, so that is the second iteration. It become 1 over minus J6 like before, but here we, as the active power is injected, so that will be positive according to the sign convention, minus JQ3 rho that we need to calculate, and U3 rho conjugate of it, minus J4 into 1 as it is the voltage at the slack bus, minus J2 into U2 rho that we will put. But first we, as I mentioned, first we have to determine this value, and now once we determine it, we will put the value of the Q. Also we know this from the first iteration, which is this one, and we will put this value here of the U2 for the first iteration. We will determine U3, so we will do that, but before we have to calculate Q3 for the next iteration. So now doing that, we have to calculate first Q3, and we have already put the that we discussed before. We will exactly in the same expression, which is this one. Now we will put the updated values of the U2, the angles, and because this slack bus, so that will be 1, that is also 1, but the angles, particularly this one, that is no more 0, because for the first iteration it is 1.6 as you can see here. So putting the updated values of the angles and the voltages as well, so we calculate now Q3 2 as we have determined Q31 before. So Q31 we determined before, and now we will determine Q32. So now putting exactly in the same expression, this one, all the values, we will put the values. I will put it directly. So as you know, this is 1, that is 1, that is from the bus admittance matrix. This is 1.6, this is 0, that is after the second iteration it become 0.988 with this angle, so I will put it 0.98, it is 1, and that is the updated angle, which is this is 1.6, and that is 0.99, almost 10 degrees. So putting all these values here, I will directly write it, so that it become 1 the magnitude of the voltage is -4, which is the susceptance cause of the psi 3 angle, which is 1.6 as we have determined before, minus the angle at the slack bus, which is 0. So that is the first term. The second term become the U2, so which is now we have determined it is 0.988, and then the voltage at the voltage control bus, which is 1, and the term which is susceptance, it is -2 cause of the angle, which is psi 3, which is 1.6 minus psi 2. So as the psi 2 angle is -9.99, and we have already a negative sign here, so that become plus 9.99, and the third term which is now again the voltage at the voltage control bus, so it is 1 with the susceptance, that is 6 cause of the psi 3 minus psi 3, which is this term, so that becomes 0. So it comes out to be minus 3.998. This term gives minus 1.9357, and the last term is straightforward, is 6. So now Q32, it become 0.0663. If now we compare it with the value that we determined before, for the first iteration it was approximately 0, but now we see here the updated value is 0.0663. and as you remember from the previous delivered material, right, at the voltage control bus, which is this one, at the voltage control bus, the voltage magnitude remained fixed for any value of the reactive power injected, so that would remain the same value. So now we go for determining the U3 according to this expression. So now we will determine U3 again, this one, and putting the values of the Q3, similarly P3, which is given. So now putting updated values and also the first iteration value of the voltage with a conjugate. So putting the updated values of the voltages and also that of the Q, we have to calculate the voltage at the voltage control bus for the second iteration. So let's do that now. We will now put here this value which is determined here. So now if we put, I hope you see it now, we put this value here and also the voltage magnitude from the first iteration with the conjugate and this value, and this is this voltage at the slack bus. So now putting these values, the U3 2, now for rho equal to 1, rho equal to 1, U3 2 becomes 1 over minus J6 0.5 minus J 0.0663 over the conjugate of the voltage for the first iteration, and that was 1 with an angle of 1.6. so this is this value, which now we will take the conjugate of it, should become minus, that will become a minus. So now it is 1 minus J 0.028 minus J4 minus J2 with the voltage, this one we will take now this value of the voltage U2, we put it here, so that become 0.0 0.973 yeah, 0.973 minus J 0.1715, and we close this one. So the value now we determine, it is equal to after putting all these, after making further calculations, we arrive to value that is 1.0039 with an angle of 1.501 degree. Now one thing which is important here is to know that at the first iteration we get the voltage magnitude which was 1 and the angle is 1.6. After the second iteration we determine it, the voltage magnitude is 1.0039 and 1.501. Now while knowing that the voltage magnitude given at the voltage control bus which is 1, we need to correct this value because the voltage should not exceed 1 value. So now applying the correction formula, according to which the correction of this can be made in a way that U3 to correct value become U3 magnitude, this is the correction formula, according to this one, that will be U3 2 divided by the magnitude of it, U3 2. So now if we look here, this can also be written as magnitude with angle. So it means the magnitude will cancel out, the angle will remain the same, but here the magnitude would become 1. So because the voltage magnitude at the voltage control bus is given as 1, so according to this formula we can correct this value. So putting now U31 which is given as 1 and the magnitude of it which is 1.0039 and the same as this one, I should have put it even in the rectangular form, which is equal to that one is equal to 1.0036 plus J 0.0263. So now putting this value here, which is 1.0036 plus J 0.0263. So now we can correct it and it will become the value after applying the correction will become U3 to correct value will become approximately 1 and with an angle of 1.501. So now if we compare it with this one, when we apply the correction, so the magnitude now retained 1 and the angle is basically determined in this way, so that become 1.501, which is approximately the same as this one, but the voltage magnitude is now retained to 1. So this is the correct value of the voltage at bus number 3. So we have now determined, so psi 3 to become 1.501 degree, and that is what we were supposed to find. One can further proceed even with the iterations, but I will stop here, as in the question it was stated that we should perform the calculation only for the 2 iterations. The third task was related to the active power flow on all the branches and the injected active power at the slag bus. So let me once again, so we in the third task are supposed to find the active power flow on all these branches and the active power which is injected into the slag bus. So as you know that, I mean, if you look into this network, we do not have any active power loss on the transmission lines because it is considered as lossless transmission line. So it means that if we calculate the slag bus power, the injected power here, we have to find it, but knowing that the injected power here is 0.5 and we do not have any active power losses, and that is 1 per unit, so it means the power which is injected here should be approximately 0.5, because the two injected powers should be equal to this one. So it means if our calculation is correct, this power injected here should be more or less equal to 0.5 per unit. So now let's do that, but we have also to calculate the power flow on the branches as well. So we know that the active power flow is equal to, between 2 points, is equal to, let's say 1 2 is equal to u1 magnitude u2 magnitude over x1 2. For a lossless transmission line, we have already discussed this expression before, and that is sine of psi 1 2. Okay, so now it can be even written in this way, because this is 1 over x, which is b, and this is lossless transmission line. Lossless transmission lines are given in the network. So now 1 over x is b, so that become b1 to u1 u2 sine of psi 1 minus psi 2. So now putting all the values, the voltage at the slag bus, the voltage which we have determined after the second iteration, that found out to be that was found to be 0.988 with this angle. And so putting these two voltages, and also we know this is 0 angle, and that is minus 9.99. so now putting these values, so the active power flow from bus number 1 to bus number 2, from here to here, the active power flow on this branch we will find that now using the voltage here, the voltage after the second iteration here, and also the susceptance value. So that is now 4 into the voltage magnitude, which is 1, into this one, which is we have determined it to the point that was determined as 0.988, this value 0.988 after the second iteration. So putting this value now, 0.988 sine of this angle is 0, this is minus, and we found it also minus 9.99. so putting 0, and that will become positive 9.99. so that comes out to be 0.6855 per unit. In a similar way, we find P13. Now it will become, this will be B13 U1 U3 sine of psi 1 and psi 3. So putting all those values, B13 U1 magnitude U3 magnitude sine of psi 1 minus psi 3, that comes out to be as if you look here now, the voltage at the voltage control bus, which we determined after the second iteration, that was find out to be with a magnitude of 1 and an angle of 1.501. so it means that now the angle at the voltage control bus is more than that of the slag bus. So as we know that the active power flow in this case would be negative, because active power is sensitive. You know that it is sensitive to the difference of the angle. So this angle will become negative, because this is 0, that is 1.501, so that would become negative, and the sign of the negative angle is negative, so that becomes minus 0.104 per unit. In a similar way, one can find the power flow which is flowing between branch number 2 and 3. That can also be find out using the same expression as here. So P23, it would become B23 U2 U3 and sine of, that is U2 U3 sine of psi 2 minus psi 3, and that becomes out to be putting all the values. Now again, if one look here, that is basically psi 2, it is minus and this angle is positive. So it means if the angle here is more compared to this one, so but we are finding P23 and that is because this angle is negative, this is positive, so this would be negative. If we were supposed to find P32, it means that the active power should flow from here to here because the angle here is more than this one. But as we are finding P23, if it would have been the other way around, P32, this would become psi 3 and minus psi 2, so then this angle would become positive. But in this scenario, that is negative angle, this is positive, but with a negative sign it make it negative, so this value will also comes out to be negative, which is minus 0.3936 per unit. Anyhow, we are not interested in this value, but it was basically asked in the task. So calculating it to be minus, but if we make it P32, this angle will become positive and this will also be then positive because the angle at the voltage control bus is more compared to this one. It is negative, that is positive 1.5 after the second iteration. So now the last task, which is to find the injected power at the slack bus here. So if this with the injected power here will be equal to the power which is flowing here and here, so it means P1 will be equal to P12 plus P13. So now putting P12, which is 0.6855 plus P13, which is negative. So putting now negative value minus 0.104, that comes out to be 0.582 per unit. And if you now look to this value, what I even mentioned before, that looking into this value, the total power consumption, the active power consumption at the load bus is 1 per unit. 0.5 is coming from the voltage control bus, so it means 0.5 should come from here because the loss of the active power on the branches is 0. It is only consuming reactive power. So 0.5 should be coming from the slack bus. So now if you look here, that is 0.582 and it is after the second. This value is calculated based on the voltages and the angles determined after the second iteration. If we go further, that would, I believe, further reduce. So but anyhow, if we take it approximately 0.5, so then 0.5 coming from the voltage control bus and 0.5 coming from here, that completes or that basically fulfills the need of the active power consumption at the load bus. So that is what we were all supposed to do in this particular exercise. Thank you very much, and I pray for all of you. I wish you happiness and keep safe and keep also other people safe. So thank you very much once again. Assalamu alaikum wa rahmatullahi wa barakatuh.